So let's start by opening and showing an image to see how that works. So the first thing I want to do is from the Python image library, from pill import image, this needs to be capitalized just like this. And I'm going to put file name in a string. So mine's going to be sunset.jpg. And then I'm going to use what's called the image open. Okay. So I'm using the image object and using its open method to give it the file name as an argument. And all of that is going to go into an image object. And the image object is a pillow image object that I can then do things with. In this case, I'm just going to use that object's show method to cause that to show. So in code, I'm going to use sunset.jpg. When I run this code, what it's going to do, once it gets going, is it's going to open and show the image that I just indicated. So I want you to get to the point where you can do this, where you can open this up. Now, a couple of things about this. Notice, this doesn't open in PyCharm. It opens outside of PyCharm. This actually triggers whatever the computer's default image viewing program is. In this case, my default image viewing program is Preview. I think Windows has an image viewer or something like that that's pretty similar. But basically, whatever the default is, it's going to open it in that. Also, I want to point out, look on the very top of this image window, near the left-hand side, you'll see a file name. What kind of file is it now? It's a ping, right? So when I open this using Pillow, I convert it to a Pillow image object, it's working with it as a ping file. The reason for that is that whole lossless thing means it's not going to make it look any worse just by converting it to a different file type. So it's going to work with that as a ping file. If I view that file, it's going to be a ping file. I can turn around and save it back out as a JPEG if I want, or I can save it as a ping. But you can see the quality is just fine so far. Okay, so this is how you open a ping file. And now, once you get to that point, if you can get to an image, showing an image file, then you can start doing some of this other stuff that is really fun to do with images. So let's talk about some of the other things we can do. One thing you can do is you can access the properties. Okay, just think of all the words that we learned in the last 2 weeks about objects, right? So this is the format property of that image file. That image object, which is based on a class in Pillow, has properties. It has a format property, a size property, which is a tuple that contains the pixels across and the pixels up and down. An image mode, RGB, now that you know what that means, right? If I had opened a transparent ping, it would say RGBA, and now you know what that means. So you know some things. What it's telling you when you ask for this info is stuff about the image. Now, in our Python Canvas shell, under week 16, if you go to files, you should see this pillow practice file. I think it's there. Let's see. So many things. There it is, M16 pillow practice. This is this file. And it's got a lot of code in here that's commented out. And the reason for that is because I have all kinds of things that I'm going to walk you through that will do stuff with your image. Now, if you just take this image and change the file name to the image you just saved, then you can just go through and uncomment some of these things and see how they work. So when I run this, now it's going to show the image, and it's also going to tell me the image size, which is 4,274 pixels across, 2,839 up and down. So I can also do like image width if I want. If I don't want to deal with a tuple, I can just say image width. I can find out how many pixels wide it is. Okay, so there's my pixels wide. That's actually how many little squares make up that image. So if I say image size like this and I run it and I get back 4274 times 2839, I could actually say print image width times image height. If I do that, that's how many pixels are in this image. Okay, 12,133,886 dots. Each one with an RGB value. So that's actually how many things are there.